Hi, my name is Cassandra Lopez, and I'll be talking about black holes. So black holes are one of the most fascinating and intriguing objects found in outer space. A black hole is basically a region of space resulting from a collapsed star, which is a specific black hole, but I'll get into that later. So basically, they are formed when stars die and they collapse inward, creating an intense gravitational field. So stars are massive collections of mostly hydrogen atoms, and in their core, nuclear fusion crushes hydrogen atoms into helium, releasing a huge amount of energy, which pushes against gravity, maintaining a balance between the two forces. So I actually have an example for you. It's like a home experiment, I can say. So basically, I have a balloon inside of this, and the balloon would act as energy pushing back, and then the gravity is the aluminum foil pushing inward. So even it doesn't matter how much gravity I push in, the energy keeps pushing back. So it's a balance between the two. So the star would be fine, and it's balanced. Um, but for stars with much more mass, it allows them to fuse with heavier elements until it reaches the element iron. So basically, the fusion process that creates iron doesn't create any energy at all, making iron build up in the center of the mass, unstabilizing the balance between energy pushing out and the center and gravity pushing in. I'm sorry, making the core collapse. Moving at a quarter of speed of light, feeding even more mass into the core. The star is massive enough, the entire mass of the core collapses into a black hole. So I have another experiment type thing. So basically, this is the star with the iron built up inside. So it's not pushing any energy out. It's only gravity in. So basically, hold on. Sorry. So basically, crushing it inside the core, making it collapse, right? But if it's it's a big star, then it would make it into a black hole, pulling stuff in. Right. So black holes are objects of extreme density, with such a gravitational attraction that even light from can't escape from it. So since there's nothing faster than light, everything else will get dragged into it too. The event horizon is the border of the black hole, which is basically the point of no return. That's the reason why it's called a black hole. It's because it sucks up all the light that hits the border or the event horizon and then reflects nothing. There's so many black holes in the universe that it's impossible to count them all. But we do know that there are about 100 million of them in our galaxy. So the closest is V616 Mon, that's what it's called, and it's located about 3,000 light years away, and it has between 9 to 13 times the mass of our sun, which is pretty big because the sun is pretty big. So basically, there's three types of black holes. There's stellar black holes, which is when a massive star collapses, which is the one I was talking about before. They're super massive, which we don't know exactly how they're formed, but we do know that they have mass equivalent to billions of suns, and they usually exist in the center of most galaxies, including ours. They continue to grow because of their location, and they have been feeding for millions and millions of years. So the last one is the miniature black hole, which has not been discovered, but we do know that it should have a smaller mass than our sun. These each fall into their categories depending on their masses, and each one of these are formed differently. But we only know how the stellar one is formed. So, as powerful as black holes are, they eventually evaporate through a process called Hawkins radiation. To understand how this works, you have to look at empty space. It's not actually empty space, but it's filled with particles that pop into existence and annihilate each other. When this happens at the edge of a black hole, one of the particles will be drawn into the hole into the black hole, and the other will escape, becoming an actual particle. So the black hole starts losing energy, making it smaller, and in the last second of its life, the black hole radiates away with so much energy that it causes a huge explosion. Although it sounds like a very fast process, it's actually extremely slow. So the last kind of thing I wanted to mention was this really awesome picture that was taken earlier this year or earlier this month. I don't really know the timeline, but it's actually the first picture ever taken of a black hole. It is actually a super massive black hole, and since it's a supermassive black hole, it's actually located at the center of the galaxy, and this black hole is actually called the Sage A star, and it's actually 55 million light years away. Before this image was released, there was only really simulations of black holes, and I think that this is such a big breakthrough and a huge step forward in astrobiology, because now we have concrete evidence and an actual image instead of just predictions and simulations. So yeah, I thought that was really cool. If you guys want to look more into it, there are research articles and videos about the picture explaining how they captured it and everything. But yeah, I just wanted to mention that because it was really cool. So yeah, thank you so much.